Hi, this is the continuation of classifying and writing the equation for conic section. The last instructional video, I gave an example numbers 1 and 2 where we talked about parabolas. Let me pull out the rules that I showed on the last instructional video. The standard form to classify the conic section is given as up here. And once you identify the A, B, and C, and you substitute it into the discriminant, if that turned out to be less than a 0, it was either a circle or an ellipse. If it turned out to be a 0, which we dealt with last time, it was a parabola. And of course, if that discriminant became greater than 0, a positive number that is, we were looking for a standard form of a hyperbola. On number 3, if you identify the A, B, and C, A is equal to 12. B, well, there is no B. There is no X and Y term over here, so it's a 0. And C is a 20. Now we're going to go the discriminant b squared minus 4ac. Follow through with it, we get 0 squared minus 4 times 12 times 20. What is that? Well, that's 4 times 12 is 48. And 48 times 20 is double. It's 960 with a 0. And it's a negative. And since it's a big negative, which is less than 0, we have a possibility of this being a circle or an ellipse. Circle or an ellipse. Now, we didn't talk about this, but there's a distinction between circle and ellipse. To be a circle, you have to meet 2 criteria. First, you have to ask yourself, does b equal 0? Yeah. And it must be, does A equal to C? No. Then it is not a circle. It has to be both b equals 0 and A must equal C. So it is not a circle in this case. To be an ellipse, which is the only other option, b does not equal 0. Or, if you thought, hey, no, not yet, or A does not equal a C. So in this case, A does not equal a C. So therefore, we know it's an ellipse. Yeah, you have to memorize this. And so, now we know by looking at this, it's an ellipse. We're looking for an ellipse. Alright, so, remember in the past, the basic form of an ellipse was given as x squared over a squared plus the y squared over the b squared equaled to 1. Same was true if we had a vertical major axis given as x squared over the b squared. The bigger number always goes with the major axis. So if it went along the y-axis, then the a squared goes over here. That's the way we determined it. Well, now, since we have the midpoint is not the origin anymore, now we have to say x minus h squared over a squared plus y minus the k squared over the b squared equals 1. So that's the standard form. That's the standard form for horizontal major axes, elongated along the horizontal axis. Okay? And same will be true if it was vertical this way. So in order to write the equation, we have to complete the square. So let me show you this over here. So we're going to group it. Take these two x's together. Commutative property. And we'll take the y's together. Plus the 20y squared and the 40y. Well, what about the negative 37? Get that out of there by adding 37 to both sides of the equation. So equals positive 37 now on the right side. Now we're going to complete the square by first taking the x terms and factoring out the coefficient 12. So what remains in this case is x squared minus x. Now to complete the square, you take the b, which is -1. And what's half of -1? Well, it's 1/2. And what's a square of a 1/2? It becomes 1/4. The second one now. Plus, what do these two y terms have in common? Well, they're divisible by 20. So factor out the 20, which remaining is y squared plus the 2y. What's half of the b term of the y? Half of 2 is 1, and 1 squared is still 1. And that equals to 37, which we kicked over. But now here's the kicker. You don't just because you put a 1/4 here, you don't just put a 1/4 there. Remember, it's 1/4 with the leading coefficient 12. So you have to multiply these two, then take that product, give it to the right side. So what's 1/4 of 12? Well, 4 reduces 12 3 times, so you have to add 3 to this side since there's 3 over here as well. How about over here? Yeah, 1. You don't just put that 1 because you put 1 there, you don't put a 1 there. No. 1 times the leading coefficient 20. So you put a 20 over here as well. Now we're going to factor, but we're going to do it in a single swoop here. X times -1/2 squared would give you the trinomial here. Because what's 1/2 plus 1/2? The 1. What's 1/2 times 1/2? 1/4. See? And here we got 20 times. I'm going to factor this guy as well. Y plus 1. You see that? What's 1 plus 1? 2. What's 1 times 1? 1. So it's squared. And then when you evaluate all the constants on the right side, 37 plus 3 is 40. 40 plus 20 is 60. You're thinking, it looks nothing like this yet. No, not yet. And now what you want to do is get rid of 60. How do you make this into a 1? Is multiply by its reciprocal, 1 over 60. And you're going to distribute that new coefficient, the factor, to every one of these terms inside the parentheses. So it's a 60 and 12. Well, 12 goes into 60 5 times. So that becomes x minus 1/2 squared over 5. 20 reduces 60 3 times. So y plus 1 squared over 3. And 60 cancels out to 60, so there it is. So it looks like it now. But how do you make that into a square form? Well, that actually, a, remember the bigger number, or the a follows the major axes. So a was the square root of 5? Square root of 5. Was the square root of 3? Square root of 3. Since this is an ellipse, we need the two foci. How do you find that? Well, remember, it is the inverse of a sum of the x squared and the y squared, okay? So you have to say square root of, and then since the inverse, a squared minus b squared. So a squared, a is square root of 5, so square of that is just 5. Minus the 3, and square root it. So what's the c? What are the foci? They are actually square root of 2 spaces away from the new midpoint. How do you graph that? Well, here's how it's done. First of all, remember the new HK now, the new translated midpoint, x is inverse of -1/2, which is 1/2 and -1. So from the origin, here's 1, here's -1. So from here, we have gone 1/2 and down 1. There it is. That's the midpoint. Now, where are the vertices? Well, the major axis is horizontal, so it's a square root of 5 away from here. What is a square root of 5? Well, a square root of 5, is approximately 2.2 units away from the new translated midpoint. And the square root of 3, the co-vertices. How many units is the square root of 3? It's about 1.6 units away. And where's the foci from the midpoint? Well, square root of 2 is about 1.4 units away from the midpoint. Hang on there. We're almost there now. And so let's start graphing. This is the midpoint at 1/2 and -1. And so the vertices, since it's a horizontal major axis, from here, we're about 2.2 units away. So if we're at 1/2, here's 2, here's 3, and let's just put it all the way. Here's 4. From here, it's 1, 2, and about 2 units away. There it is. And the coordinate for that, here, look at this, check this out. It is 1/2 plus square root of 5 units away from that 1/2 and -1. That's the coordinate. So same must be true on the other side. So from here, -1, -2, somewhere -3. So from here, we're going to go 2.2 units, 1, 2, and some odd 2 units right there. So how do you indicate that coordinate? We say 1/2 minus square root of 5, and the coordinate is -1. Where am I? There I am. Now how about the co-vertices on the other side? Well, from the midpoint, it is square root of 3 units away, which is about 1.6. So from here, 1.5 and 6, yay, around here. So how do you indicate that? Well, it is 1/2 and -1 plus square root of 3 units away. We're almost there. And from here, here's -2, here's -3. So from here, when we go the other side of the covert vertex, square root of 3 units away, it means from here, 1.5 and 6 here somewhere. So the coordinate becomes 1/2 and -1 minus square root of 3 units away. So there it is. I could estimate my vertex. There it is. Whoa, bad rendition of an oval. Where are the foci? The focus is about 1.4 units, or square root of 2 units away from the midpoint. So here's 1.4 and 1.4. There's my focus. Coordinate, I don't have much time right now, but there it is. Whew. Okay, so if you saw my ellipse, problem number 3, why don't you try number 4 on your own? Okay. Alright, so back to the rules and the standard form so you can see. By looking at the standard form, you could see that the A, yeah, you should always identify the A, B, and C. The A is 9. The B, there isn't any. See? There is no XY term here. And the C is 4. Now you do the discriminant. B squared minus 4AC. B is 0 squared minus 4 times 9 times another 4. Whatever it is, it's going to be a huge negative number. I think it's 144, by the way. And since this is less than 0, it's going to be a circle or an ellipse. It's a circle or an ellipse because it's less than 0. So which is it? So you ask yourself, does B equal 0? Yes. And does A equal C? No. So our only other choice is that it's going to be an ellipse. Yeah, ellipse. We're looking for an ellipse now. Okay? Alright, so once again, the ellipse with the translated vertices is written as x minus h squared over a squared plus y minus the k squared over b squared is equal to 1. We're trying to make it look like this. So, let's take this given equation and let's group them. Put all the x's and the y's together and, 24y. And move that 36 term over the constant. So 9x squared Here's a 36x. Put them together. Here's a y term, 4y squared. And there's another y, negative 24y. And that's minus 36 to both sides. So we could get that constant out of there. And we're going to complete the square in a group form. What do these terms have in common? Well, they have a coefficient of 9. So take out the 9, divide out the 9. What remains is x squared plus 4x. And we're going to complete the square simultaneously. The half of the b, half of 4 is 2. And 2 squared is 4. This one's coming out nicer than the other one. Plus, what do these y terms have in common? They have a coefficient divisible by 4. So factor out the 4. What remains is y squared minus 6y. And let's complete the square for that guy too. Half of the 6 is 3. 3 squared is 9. Equals negative 36. Now you remember, just because we put a 4 here and a 9 here, that's not what we had on this side. We have to remember the coefficient goes together. So 4 times 9 is 36. So give a 36, knowing that this is going to cancel. And this leading coefficient 4 for the y, and that 9, complete the square 9, multiplies. So we have to give another 36. And now let's simplify the terms into a single terms for these x and y trinomials. So we get 9 times x plus 2 squared. And here, 4 times y minus 3 squared. Why is it minus 3? Well, minus 3 plus minus 3 is minus 6, the middle term. And minus 3 times minus 3 is positive 9, the c term, the AC factor. Now over here on the right side, 36 and 36, additive and inverse, they cancel. So that remains with the 36. Now how do I make this into an ellipse form, the standard form? How do I make that constant into a 1? You multiply the reciprocal of the constant, 36, to all the terms of the equation. So it's 1 over 36. So when I do my distributive property, the coefficient 9 reduces to 36 4 times. So x plus 2 squared over 4. Plus the second expression, the leading coefficient 4 for the y, reduces to 36 9 times. So y minus 3 squared over 9. And of course, the constant 36 reduces to a 1. Yay! Now remember, the A follows the major axes. Since the bigger, this is going to be a vertical ellipse. Because the bigger number, the A, follows the major axes. So the A is no, it's not 2 squared, it's actually 3 squared, so it's 3. And so the smaller number, the co-vertices, is going to be the 2 units away from the middle, the midpoint. Where's the foci? Well, remember, it is a difference, the inverse of the addition sum here. So square root of a squared minus b squared. Oops, I said minus and I put a plus. And so when I evaluate that, I get, well, a squared is 9 minus 4. So that's going to be a square root of 5. What approximately is the square root of 5? If I did it, I forgot. When you get to my age, you forget things. You even forget what you had for breakfast. So square root of 5 is approximately 2.2. That sounds familiar. So 2.2 units away from the midpoint, the translated. And what is the midpoint? What is the h and the k? Well, that's given over here. That's the inverse of the given. So it's going to be negative 2 and positive 3. I think we have all the information needed to graph now. And so, let's see. The midpoint of the entire ellipse is at negative 2 and 3 from the origin. It has translated. So, from the origin, in the olden days we would have drawn it like this. It went to negative 2 and 1, 2, 3. Here's the new midpoint now. So from that midpoint, now we know it's going to be a vertical major axis because the A always follows the major axis. It's the bigger number. So what's the distance away from the midpoint? It is 3. So from here, 1, 2, 3. There it is. And what is that coordinate of the new vertex? It is actually -2. And 3 units from the 3 is going to be, I guess, 6. That means 3 this way also. 1, 2, 3. So the other point is at -2 and 0. Okay? Now what are the co-vertices? From here, the midpoint is 2 units away. So I guess to the right, 1, 2. So the coordinate is 0 and 3. Since 0 right there, I'll use that. And then also to the left from the midpoint, 1, 2. So what's the coordinate for that? It's -4 and 3. So I could draw my ellipse elongated vertically. So where's my focus? It's approximately 2.2 units away from the midpoint, or square root of 5 away. So 1, 2, and 0.2. Somewhere there, and 1, 2, point somewhere there. There's my focus. Okay? There it is. H and K, standard form, and the focus. Alright, good luck.